Okay, this is another type of pattern. Is to take a value of the first or few terms and define it by some sort of general formula. And this is what's called a recursive sequence. Recursive means what you're currently defined by depends on what the previous value was. So not only are we going to have a formula in terms of n, but we're also going to have a statement that involves another number in the pattern. Okay, so let me kind of show you how to read this. So they're telling us this S sub 1 means the first number in the pattern is 1. So when n is 1, it's 1. They just told us that. Okay, when n is 2. All right, so let me tell you how to read this. This says S sub 2, so the second number is n, so 2 times the number of the pattern of the n minus 1, right? So that's 2 minus 1 is 1. All right, so our second number is 2 times the first number, and the first number in this case was 2. And that works out to be 2. Okay, the third number, so our third number in the pattern is n, and in this case is 3 times the pattern of the 3 minus 1 position. Well, 3 minus 1 is 2, so as you can see, we're dealing with 3 times the value of the second number, and the value of the second number was 2, so that means the third number in the pattern is 6. Okay, so the fourth number. So n is 4 in this case. We're going to speed this up a little bit. So the fourth number would be 4 times the third number. And the the third number was 6. So that means the fourth number is 24. And then the fifth number would be 5 times the fourth number. So that's 5 times 24. And that would be 120. Okay. So any pattern that fits this particular mold, we call a recursive sequence. It's where n, the position in the pattern, is defined by the value n and some previous number in the pattern. So the fact that we're using the previous definition or previous term to define the new term, we call that recursive. And there's a nice famous recursive sequence, which we're going to look at here next. Okay, and so take a look at that particular pattern. So we have the first number is 1, so they're just telling us that. First number is 1. The second number is also 1. That's what that u2 equals 1 means. And then they're saying u of n plus 2. Okay, so I want a 3. I want the third number in the pattern. Well, what n, so if I have n plus 2, what n would generate a 3 here? So what plus 2 gives me 3? Well, that's a 1. So u to the 1 plus 2 is how we say the third number would be u to the n, so u to the first, plus u to the 1 plus 1. Okay, so that translates to the third number is the first number plus the second number. Okay, well, what was the first and second? The first and second was 1 plus 1, so that means 2. Okay, what about the fourth number? So the fourth number, and I'm going to write this out a little long. Sorry, I meant to write n there. Do this a little long ways. Okay, so I want what n, so what number n would give me a 4 if it's n plus 2. That would be a 2. Okay, so that would be the second one plus 2 plus 1. So translate that out. That means the fourth number is the second number plus the third number. Okay, well, what was the second number? The second number was 1, and the third number was 2. So that puts that at 3. Okay, so hopefully we get a better, stronger sense as how to read this. So let me kind of summarize this a little bit differently here. Then I'll tell you what this is called. Okay, so in essence, it's a 1 and a 1. We add that together to get 2. 1 plus 2 is 3. What would the next number be? 2 plus 3 is 5. 3 plus 5 is 8. And then 13. Right? We can keep going on. Hopefully you kind of see the point behind that. This particular sequence is named after a famous Italian mathematician. He's the one that came up with it. But it's called the Fibonacci sequence. Okay, and I always tease in my face-to-face classes, you can't just say Fibonacci, you got to go Fibonacci, like you're ordering good Italian pizza, I guess. It's a fun word to say. Anyways, why does this pattern matter? Why do we care about the Fibonacci sequence? And the answer is because it's something we see in the real world. You know, he came up with this pattern and then went to a seashell and looked and saw, oh, wait a second, this shows up in the spiral of the seashell. That's weird. We'll name a pattern after you. Okay, the next type of sequence we're going to look at is called an arithmetic. I know it looks like arithmetic. It's pronounced arithmetic sequences. These are sequences, and these are patterns based on adding. Anytime where we're going to add a number, add a constant to get the next term of the pattern, we consider that to be arithmetic. So the formula definition of this is we have some sort of common difference d, and we're going to add that d to the first term. That's going to give us the second term. And then we're going to double the difference and add that to the first, and they'll give us the third. So we're constantly adding that term in. The formula for the nth term, so instead of, we'll kind of look at how to generate this out, but instead of looking at how to get the first number and the second number, the third number, what if I want to know the 57th number? Well, working it out, I'd have to calculate the first 56. There's got to be a way that we can kind of shortcut this. And so we can collapse this down into this little formula here, and that'll generate the nth number for us. Okay, so let's kind of look at a specific pattern here. I'm going to give us that the first number of the pattern is 2, and I want to know what so the first number is 2. I want to know what the second, I want to get up to the 4 numbers are. Okay, so that means I'm going to add 3 to 2, so 2 plus 3 is 5. That'll give me the second. The third number is I want to add another 3, so 5 plus 3 is 8. And then 8 plus 3, and this is our fourth term, is 11. Okay, so the fact that I just added 3 to the previous number, that I was using a recursive pattern to generate that, I could have just doubled it, the difference. So if I say I went here to the third number, that common difference is 3, so if I doubled it, I get 6, and 6 plus the original is 8. If I tripled it, triple the difference, plus 2 gives me 11. Either way, so that's what the first 4 numbers look like. So the nth number, coming over to our nth pattern, would be the first number, in this case 2, plus n minus 1 times the common difference, which in this case is 3. Now we can actually simplify this a little bit. We can do a little bit of combined like terms. So I can distribute the 3 in, for example. And I notice that the 2 and the minus 3 combine together. So that would be 3n minus 1. So you tell me what n you want. You tell me what position in the pattern you want, and I can generate that out. Okay, so for example, kind of illustrate this kind of the long way. Given the following is arithmetic. So they're going to tell us it's an arithmetic sequence. I don't have to show it, just they tell it to me. Starting off with 13, 7, and 1, find the 200th term. Well, let me look at the nth term formula for a second. The nth term is the first term plus n minus 1 times the common difference. So I need to know a few things. First off, what is the first term? Well, they told me it starts at 13, so that's going to be our first term. What about the common difference? Well, notice if we go from 13 to 7, right, I subtracted 6. If I go to 7 to 1, I subtracted 6. So how are we getting there? We're subtracting 6 each time to go from the first number to the second number and the second number to the third number. We're just going to subtract 6. Okay. So our nth term would be 13 plus n minus 1 times negative 6. And again, we can clean this up. We can distribute and combine like terms. So that's 13 minus 6n plus 6. And I notice the 13 and the 6 give me 19 minus 6n. All right, so there's our nth term. It's not the answer to our question, but it is just a nice short formula for finding any given position. Well, I want to find the 200th term. And here's where the power of this formula really helps out. If I didn't know this formula, I would have to figure out the first number, the second number, the third number, the fourth number. I'd have to go all the way up to 199, and then I could subtract 6 and get the 200th number, right? Well, with this formula, I can just say, well, the 200th number is 19 minus 6 times 200, and I can just multiply that into a calculator and figure that out. Let's see, so 19 minus 1200. Actually, this is small enough, it's not that bad. So negative 1,181 would be our 200th number.